So we're looking at examples of substitution, just practicing some more integration. So again, the substitution idea is that if we look at this function, there's no rearrangement that gives us some standard integral. So our only strategy right now, and there are a few others, but the main one and the one that we're going to use is integration by substitution. So the idea then is we need to look for an inside function such that the derivative of this accounts for the outside leftover function. Okay, so we're going to let u equal the inside part here. Now we could let it equal to x squared. Here I'm going to just let it equal to 1 plus x squared. Okay, that 1 doesn't really affect integration or anything, so it's easy enough to probably put it into the u. So my derivative then, du, becomes 2x dx. And so I can rearrange this, so du over 2 is equal to x dx. And there it is. There's my x dx I'm looking for. Okay, that will allow me to convert the dx into a du form, and then allow me to do the substitution. And once I do the substitution, okay, so I'm going to have the integral of 1 over power 4, okay, and then the u function, I can replace the 1 plus x squared with the u function. I can replace the x dx with a du over 2. Okay, so at this point here, yeah, that's all. I've done my substitution. Everything now is in terms of u, so I can then integrate normally. So I'm just going to clean this up a bit. I'm going to take that 1/2 out because that's not going to be involved in the integration. Okay, and I can just integrate with respect to u, so I end up with 1/2 u to the power -3 divided by -3 plus c. So when I simplify this, I end up with 1 over, so -1 over 6 u cubed plus c, and there's my indefinite integral. Okay, and I'll call that one just y. So again, we want to try to do the same thing here. We're looking for an inside function whose derivative will show up on the outside. Okay, so I'm going to choose in this case the log x as my inside function. So it's going to be embedded inside a reciprocal function, okay, or 1 over x function, and the derivative of that will account for that extra x. So I'm going to let u equal the log x. My du then, when I differentiate the log x, I get 1 over x, and then I'm going to move the dx over, so I get 1 over x dx. So there it is. There's the outside function that needs to be accounted for with the derivative. Okay, so this one works. So I'm going to then replace this. I'm going to end up with the integral of 1 over, that's going to be u. There's my 1 over u. And then I'm going to replace the 1 over x dx, which is right here. I'm going to just replace that with a du. So I've completed my substitution. I now have this in terms of u, a variable u, and the variable of integration is u as well. So I'm going to anti-differentiate this. So I get ln u plus c, and so I can substitute back in. The u was log x, so log x, just make that look more like log x plus c. And there, this is my inside log x. Okay, that was my u that I had over here. So that's my derivative. So if I want to, again, we should check this. So I'm going to check, I didn't check the first one, but let's check this one. The derivative of log. Okay, I differentiate this. I'm going to end up with 1 over the inside, log x. Then I have to apply the derivative of the inside, 1 over x. Yeah, I end up back to where I started from. That is the correct integral. Okay, so this one here, well, if I multiply it out, yeah, I get square root plus x. No, that doesn't really work out. But if I leave it in this factored form, I can see that if I choose this as my inside function, really I don't have much choice, but if I choose that whole thing as my inside function, that can account for this outside piece here. And I'm going to include the 1 in there because it's a lot easier to deal with that extra constant in the derivative because it just disappears than trying to keep track of it in an integral. So I'm going to let my u equal 1 plus square root x. And then my derivative is going to generate that 1 over 2 root x. So there's my du, 1 over 2 root x. And I'll move the dx over. Yeah, there it is. Okay, it shows up again. So now again I can apply my substitution. Okay, this is the same as the integral of 1 over u, and then I can eliminate the du, sorry, the dx over 2 root x with just the du. That du replaces all of that because they are equivalent. And then now this becomes a fairly easy integral, log of u plus c. Okay, knowing that u, we can replace that u with the original function. So we end up with log of 1 plus root x plus c. Okay, and again, I could check this by differentiating this. Okay, this is a good way to check our integrals.